Hey guys, this is Saptarshi here and welcome to our YouTube channel. Last few video tutorials, we will look at the theoretical aspects of a CNN, and today we are going to look at a basic implementation of CNN using TensorFlow and Keras. Before we jump to the implementation, let's do a quick recap of CNN. CNN is a deep learning architecture specialized to handle image data. So if you look at this image, okay, so you have image of a car and finally you want to classify that this image belongs to a car, not a truck, van or a bicycle. Okay, so it's a multi-class image classification problem and it has two components, a feature learning component and the classification component. So essentially, our human vision works by looking at a small portion of the image and in a hierarchical manner. So the same thing is emulated in this feature learning component. Okay, so we look at a small portion of the image, look at the horizontal and vertical edges. So these are called as lower order features, and then they are combined into higher order features into shapes and objects. Okay, and this is entirely called as feature learning, feature exploited by the classification layer next. Okay, which now works like any traditional neural net or any traditional classifier. Two important building blocks that are used by feature learning are convolution and pooling. Okay, and these are covered in great detail in our previous video tutorials. However, we will cover very basic about them today also. Okay, so let's now import our regular libraries, which are pandas, TensorFlow, Keras, NumPy, Matplotlib, etc. Okay, and then we will also import few of the Keras modules, okay, which will be required to build our Keras CNN model. The dataset that we are going to use is fashion MNIST, and we are going to take it from Keras.datasets, right? And here each of your row correspond to a fashion item, so that's why the name fashion MNIST. How many items are there total? So total distinct items are 10. And what is the size of the input? So it is 28 into 28 pixels, right? So the class names are not there in the dataset, which you'll need to assign manually, which are like t-shirt, trouser, pullover. So as I said, these are fashion items. Next, what we do is we do a standardization, right? So standardization is done so that all inputs are treated equally, and this is nothing but your min max scalar. So as you know that this is an image and a grayscale image, so the value of each of the pixel or each of the cells is going to be between 0 to 255, right? So if you do a minus mean and max minus mean, it is equivalent to do a t extend by 255, right? So extend and xtest are your input training image and input test image, and the rest of the thing, right, the labels are in ytrain and ytest. We are also going to create a validation set, which is 20% of the data. So we are going to use our regular train test split. This is used typically to ensure that while training, your model is not overfitting. As neural network has more parameters, it has more tendency to overfit, right? So let's do the split. Now let's look at some of the input images, right? So if we look at some of the images, indeed there are some fashion items like dress, shirt, coat, sneaker, etc. Now let's go ahead and fix the CNN image. So why this is required? Because in your traditional classifier, a row is an input, right? However, here a matrix is an input. So you need to reshape your data into these matrices. And what are going to be the dimension of the images? So these are going to be 28 and 28, right? So we will do that, and we are keeping some batch size because mini batch training is always better for neural nets, right? And then we are doing this reshape what we talked about on xtrend, xtest and xvalidate. So now what is happening now actually, so we can do a quick check on the shape. So let's do a xtrend dot shape, and let's look at the shape now. So you have 48,000 images which are of 28 by 28 dimension, and one because number of channels are 1. So it was gray channel, that's why it is 1. If it would have been red, green, blue, then the number of channels would have been 3. Now let's go ahead and look at the convolution. So, convolution is used to create feature maps, right? So the feature maps can be your horizontal or vertical edges or some kind of shapes as well. And what you do is you have a square shaped thing which is called as a filter or a kernel, right? And which you actually stride over your input image and you get the feature map. So this is your kernel over here or filter over here, and these are applied on some part of the source image, right? So as I said that it will be applied on a patch, and you move the kernel by one cell or two cell, which is often called as the stride. So individual or corresponding elements are multiplied and added up. So it's, like you are getting a value of -8. And what happens is that if you do that, your output image is actually smaller than your input image. So if you actually want to have them at the same level, then you apply something called as a padding. Okay, so this is convolution. Now let's look at the parameters TensorFlow supports. The first parameters is filters, right? So how many filters you are going to use, so how many feature maps you want, kernel size. So like here you take a you take a square matrix, so you can take a kernel size of 3. How much stride you are going to take, so horizontal stride and vertical stride. Padding is valid, means you are not applying zero padding, so whatever is coming out, that is your valid padding. Data format none means you are not changing that, the number of channels is at the last, right? So we kept 1 at the last. Okay, so you have something like a dilation rate, which will come in a short while, and you can use activations and different kernel initializers and bias initializers and so on and so forth. Okay, and now let's look at the pooling parameters quickly. Okay, so how pooling works is similar to your filter, right? But you don't have so many operations as there is in pooling. So what you typically do is you do a max pooling. So if you are using again a kernel of size 2 by 2, so you will, if this is your source image and these are the pixels 1532, then one of the pooling options can be max pooling. So you take the maximum value 5 over here, that goes to your output, then you take a stride, and generally it turns out that in pooling you should have less overlap than what you have in your filters. Okay, again these are covered in great details in our convolution and pooling video lecture. If you look at pooling now, you say that what is the pool size, if you are applying the stride or not, what is the padding, again about the data format. So these are the typical parameters, and this is the example where you are using a filter with dilation. So typically if you see, this is a 3 by 3 matrix, however it is covering quite a longer area, which is 5 by 5, and it is actually jumping things within this area, right? Within this area, so it is considering this pixel like that, right? And so why do you do it? So if you have a very high resolution image, right, so there will be a lot of redundancy in adjacent images, so there actually dilation can help you. Okay, all right, now let's go ahead and make our CNN model. So it is also going to be a sequential model like your traditional event. And first what we are going to have is we are going to have a convolution layer. So it is a 2D convolution because our images are 2D. We are using 32 filters, kernel size is 3, means 3 by 3. We are using activation of ReLU, and input shape is image shape. So image shape is nothing but 2018 to 2018 to 1. And then we are going to add a max pool layer on top of it, right? And we are doing a pool size equal to 2, so it is a 2 by 2 kernel. Then we are flattening it, right? So we told that all the feature maps that we are getting from all these 32 filters, we will actually concatenate them. Okay, we'll actually concatenate them, and then we'll feed to a dense layer. So this will work as the first hidden layer of this classifier, right? So which has 32 layers, and finally you have a dense layer where activation is softmax, and you have 10 nodes because you have 10 corresponding classes or 10 different types of fashion active. So let's run this now. So you already know about compiling. So here you are using sparse categorical cross entropy. because you have a 10 class classification problem, right? And the optimizer that you are going to use is Adam. Again, we have discussed about this loss function and optimizers in detail in our video lectures, so you can go and visit our playlists. Okay, now what we are going to do is, so this is where the CNN is starting training. So this will typically take some time, okay, and because this will run from epochs to epochs, so for less time, we want to consume less time, that's why we are running it only for 15 epochs, right? And if you look very carefully, what is happening is that our accuracy is going up from epoch to epoch. And of course, we have kept a validation data separately, so you actually need to mention what is your x validate and y validate. In this format, if you tell, it is good enough. And it is verbose equal to 1, so essentially that means you are getting all that is happening within the model training, okay. And x train and y train are your input and outputs, right? So you have two sets of input and output. One is for the training set and another is for the validation set. So let's look at and see how far we have proceeded. So we are at the 6th epoch so far, and the accuracy, if you see, has moved from 26% to 49%. So let us make it run for some more time, right? So now 8 epochs are complete, okay, and accuracy has moved to 0.53 or something like that. So we assume that at the end of your 15 epochs, you will actually have maybe 85 to 90% of accuracy, right? And after that, what we are going to do is we are going to plot the accuracy and loss, and then finally we are going to use it on our testing set. So remember, the accuracy and loss that we are plotting so far are on your training set and validation set, right? So we like to see that how it actually performs on your testing set, okay, which will do right after we have plotted this, and this is getting stored in an object called as history, okay. So it is a object which has lot of components on this validation matrix epoch wise, so which will actually be used to extract those parameters and then actually draw it. So we are quite towards the end of the epoch, and so far the accuracy that we have achieved is around 66%, okay, not 85 or 90 what we are expecting. But if I plot it, you will realize, right, that epoch to epoch, if you see epoch to epoch, there is a rise on its accuracy. Also there is a drop on the loss, okay. And it's not overfitting because training and validation set showing same kind of curves, right? And however, it is still, both of them are showing upward trend. So for taking less time, we have trained it on less number of epochs. Now let's just apply it on our testing set, okay, and see how we are doing on our testing set, okay. And so we are getting around 62 to 96% accuracy. So quote we are not doing so well, sandals we are doing quite well. So these are actually class specific precision recall and F1 scores, okay. So this brings us to the closer of CNN. I hope you have realized how to form a CNN, how to train it, and how to validate your CNN model. Thanks guys for watching our video, and if you have liked it, please like, please give your comments, and please subscribe to our channel. Thanks once again guys.